Wow, it's really hard to see here. So thanks everybody for coming for the 4th annual Scylla Summit. Thanks Greg for a fabulous job. So let's get started. Who knows what C10K is? Let's see if I can see some hands here. No one knows what C10K is?
I see one hand in the back, one in the front.
So C10K is a problem that defines the maximum number of connections per second the server can handle. It was defined by Dan Kegel in 1999, back in the days. Now, it's a good sign that not many know here what C10K is, because it's old, and back in the days it was around FTP servers where no one runs them today. And it's really not a problem that we face today. Scylla can easily go beyond that number, and we're bounded by the 64K port limit that we have. It's not that interesting, but another anecdote is that at 2002, Nginx was developed in order to solve this problem. And it's nice to see that also in the past, when you look, people re-engineered software to provide with a better solution, better scalable solutions. So C10K is not a problem today. Today, most organizations face some other problem. I define it as D10M. Basically, the D is for the dollar, a $10 million problem. Yeah, many organizations suffer from it. And when you go distributed and you have multiple machines, the optimization problem is not just within a single server, but across your whole organization. And one of the companies called Segment blogged about their $10 million problem. Segment is a really good company and successful, and they were looking to raise their next round of funding. And everything looked good. All of the numbers up to the right, their customers were growing, everything was good. But VCs complained about their margins. They were spending too much on cloud resources. And funnily enough, 2 years ago, they blogged about $1 million problem and how to optimize it. Now, Segment are really good folks, and if you look at their 2 blogs, the $1 million problem and the $10 million problem, they have fabulous solutions over there. But it's really make you alert that you have to optimize your infrastructure, because otherwise it will keep on growing. If you put engineers together with cloud, it's like, yeah, it's like putting wood and wind in California. It's really risky. So you need to figure this out and not translate your technical debt into engineering debt. And we know it. Like all stories, probably you know it even better than I, because if you start with a single server and then the server grows and you need to have more servers like it, and you move to NoSQL, and you move there onwards to scalable NoSQL, and you do scale that, and then it becomes hard to manage, so you move to the cloud. Hello, DynamoDB. But then here you are with $1 million problem or $10 million problem. Now, you're all here because you know that Scylla can solve this problem. We demonstrated over the course of the last year how we can compact data, that 45 terabytes of data that reside in a single node, and we compact them at a pace of 8 gigabytes, not bit, but 8 gigabytes per second on the left. And also, we implemented workload prioritization and released that. We have really nice demo outside for you, where we can demonstrate multiple workloads with different SLAs, each running on the same hardware. So we have a solution for that. But today, especially for the keynote, we wanted to test our limits to see how far can we go. And let me invite to the stage Glauber, Costa, our VP of Field Engineering, that I think that by now you should all know him. And take it from here.
Thanks a lot. Welcome, everybody. You can all hear me, right? When Dor talks about our limits, well, there are many kinds of limits, but he's obviously talking about performance. To speak intelligently about performance, we need to define a problem, we need to define a scenario, like it depends on the application. The scenario that I have in mind for today, this is an experiment we have been doing. It's essentially an IoT application. It is an IoT application much like one I am sure a lot of you in the audience have in your businesses, except maybe ours is a little bit bigger. So let's look at the problem. We have 1 million sensors. Those could represent, for instance, homes and their temperature sensors. Every minute, you are sending a reading from those temperature sensors to a central database. If you look at the course of a day, 1 minute per reading, at the end of the day, you have something like 1,440 temperature points. Now I want to keep this for an entire year, 365 days. So this whole database needs to host over 520 billion data points. Data model for this application, there is no mystery there, pretty standard. We're going to have a sensor ID, right? So every sensor has its own sensor ID. Together with the date in which the reading took place, that is our partition key. And then the exact time in which that reading happened, that is our clustering key. You can support real-time queries on it. I mean, this is, again, not a secret, pretty standard. You can, given a sensor ID and a date, figure out what are all the readings that took place during that day, or even faster, what was the temperature at a particular exact time. The challenge arises if we want to do analytics over this data. So if you want to process all of that and try to extract good information out of it, if you have a database that can scan 200,000 points per second, which is like a small Scylla cluster, it's going to take you an entire month to go over all of the data. Even if you scale it by a factor of 5 and do like 1 million rows scanned per second, we're still talking about an entire week. Now, it's possible. You may do this and get a report out of it, but this can't be part of your pipeline. That can't be something that you do on a daily basis for your organization. If you want to do this, if you want to change this landscape, we need to take this to the next level. We need to do this much, much better. Now, back in 1924, George Mallory decided to be the first person to ever summit the Everest. When asked why he wanted to do this, his answer was, because it's there. Now, doing so, he inspired generations of mountaineers, but he did more than that. He inspired us too. We wanted to see how fast Scylla can go. Can we maybe take this from days and talk about hours, or even better than that? Now, there's a trivia about that, because George Mallory actually died trying to do that. And I would want to believe, without giving too much away, that we fared a little bit better, because Dor hasn't killed me. I'm still here, but we'll see how fast we can do it. Now, to make it faster, we need 3 things. We need a database that can scale up and out. We have that, that's Scylla. We need a good application that can distribute the work efficiently. And we need a good hardware platform in which to run. We know the database, let's take a look at the application. Application, as well, pretty standard. We want to take advantage of the power of Scylla, and we want to move as much work as possible to the server side. So what we are going to do is that we have this query over there. Essentially, we want to calculate in our application what is the average, what is the maximum, and what is the minimum temperature over a period of time that we're going to define. 3 months, 1 day, 2 months, the entire data set, you name it. We calculate the total number of rows, and then the sum that is needed to keep track of the average. We calculate the minimum, we calculate the maximum. And then we have a coordinator process that will distribute part of the working set, some sensor IDs with some dates, to a bunch of workers. Those workers will calculate partials using that query that you saw, and then they will aggregate back to the coordinator. Now, we saw the application. Let's talk about the hardware. To talk about the hardware, I'd like to invite to stage James Malachowski from Packet. Round of applause, please. Welcome, James. Now, James, why don't you tell us a little bit more about Packet and what you bring to the table?
Sure. Thanks for having us. Packet is a bare metal cloud built for enterprises. We have over 16,000 developers now on the platform. And we can offer you dozens of sites worldwide where you can sign up with a credit card and deploy a server anywhere in the world.
Now, James, we asked you to provide us with hardware, et cetera. What kind of hardware do you think it will be ideal for an application like that?
Yeah, so we are looking at the N2.extra-large.x86, which is sort of our standard platform for heavy workloads. 28 physical cores, 384 gigs of RAM, and 4 10-gig network ports.
Now, this kind of workload, I mean, we're talking about 520 billion points over that. That's not going to fit in memory, right? So what would you have in store for us in terms of storage?
Yeah, so one of the real key features here is we also have 3.8 terabytes of NVMe, which is a really fast disk for this type of application.
That's great. And so we have in total, as James said, like 83 database servers. That's a lot of physical cores. That's a lot of hardware. And then when you gave us 83 of those servers, how fast do you think we could do that?
Gosh, I mean, I think we're thinking in the 50, 100 million records, but not too sure.
You've seen the results? Mm-hmm. So let's share the results with the audience. James, thank you very much. So let's take a look how fast we could do this. In the first example, I want to scan 3 months worth of data. Now, keep in mind, this is a database that is also serving real-time queries. So part of that will come from cache, but a lot of that will come from storage. 3 months worth of data, that is over 130 billion points. And we have done it in 110 seconds. That's below 2 minutes. And folks, this is 1.2 billion rows per second. Now, that's right, that's over 1 billion. But this is the average of the entire thing. I actually put the graphs there so you can see. In the graph in your left, you're going to see the throughput over time that correlates with the cache miss ratio. So at times, when you actually happen to hit the cache a little bit better and get more data coming from memory, we're doing 1.5 billion rows per second. And if you see, even when the miss ratio is pretty high, over 80%, we're still doing 1 billion rows per second, which already hints on what's to come. If you look at full scan of the entire data set, where pretty much everything is coming from the storage, we are talking about over 520 billion points, and we're scanning that in less than 10 minutes. That is pretty close to 1 billion rows per second, all from storage. We did it. We summited Mount Everest, and we live to tell the tale. I'm still here. Dor hasn't killed me yet. The reason we did it is that Scylla made it easy. It wasn't even hard. And throughout the conference, I will invite you to attend the presentations, especially the ones from our engineers, in which you're going to see how we're making this even easier for you to consume that and to achieve that inside your organization. If you need this kind of performance, I can guarantee you, from storage, no other database in the market can do that for you efficiently. But even if you don't, imagine what this raw power, this raw speed can do for your analytics, your organization, your business. And last but not least, Scylla runs anywhere. We know that. But the reason we do the things we do is that we are able to exploit modern hardware. That means, of course, that a global bare metal cloud-like packet is the perfect way to take advantage of all of the power of Scylla. And for all of you in the audience today, Dor, sorry, I did it too much. But for all of you in the audience today, Packet is giving you a coupon so you can kick the tires. They have a booth outside. Make sure you talk to them. Thank you very much. Dor, back to you.
So indeed, it's not a surprise and not a secret that Scylla is performant, but we're looking to go beyond that. A couple of years ago, Mark Anderson said that why software is eating the world, and followed by Microsoft Satya Nadella that said that all companies are software companies. And indeed, if you look at it, there are weird companies like Kaylee's Jenner company, where she has a real company. It's super successful, pretty much more successful than most of the companies around here. She has a seven-person company, and it's all getting fulfilled by Shopify. So it is a software company. But let's be a little bit more concrete, and I like the observation that Jay Krebs from Confluent just made the other month, and he said, all companies are software. Now let's see why did he made this really interesting observation. Like, if you look at a business process of a loan in a bank, then what you would do traditionally is you'll go to the bank, fill a form. The form would be received by a credit officer. The credit officer will have this form on his desk for several days. He'll look at the database and decide whether you have the right credit. After that, he'll pass that form to some other person's desks, the risk officer, and the risk officer, she's going to do a similar process with her data and continue forward until the loan is approved or denied. And this process takes days or weeks in the past. Now, today, there are businesses like Next Insurance, like SoFi, like Lemonade, who can automate all of this in a fraction of a second or several seconds, but definitely not weeks. And it's all done by microservices. There are no officers. There's only services over there. And this is how they look, beautiful myriads of complex applications and databases and ETL processes. So we'd like Scylla to help with that too. We are already helping businesses to sell software and through the software to power their businesses, like Grab and McDonald's. And we also released Scylla Cloud a year ago in beta and earlier this year as GA. So it's already there, and many pleased customers are running on Scylla Cloud. In September, we launched Project Alternator to open source. And Project Alternator, for those who do not know, provides a DynamoDB compatible API in a similar way that we have done with Cassandra. Now, in September, we launched it into the open source as a project. It wasn't yet ready, but it's possible to consume it directly through the code, through Docker images. Today, we announced that we launched this project on beta on Scylla Cloud. So you can finally go to Scylla Cloud and run Project Alternator, get a DynamoDB compatible API, and it's still in beta, but it's getting better and better, and we're planning to ship it as GA next year in 2020. Now, this project, it's super valuable. We talked about cost before, and you can run a relatively moderate 3-node cluster that can do 120,000 requests per second at a cost of only $7.5 an hour compared to cost of $85 an hour that DynamoDB will charge you. So pretty effective project and launch that we have. And that definitely provides simplification for your services. But we have more than that in mind, and not just the automation and manageability of Scylla software components that we can offer. Scylla itself is getting better and better. Now, over the course of the year, we launched the cloud and the alternator and workload prioritization, and also we have great improvements to Scylla Manager that you guys will have sessions about all of these through the course of the next 2 days. But I'd like to focus on specific 3 additional features. The first one is lightweight transactions, a long anticipated feature. We waited a long time until we thought that the other components are good enough and we can proceed onward. And that gives you the ability to run transactions. So that increases the amount of use cases that you can use with Scylla. And it also allows us to use transactions as a building block for the database. We'd like to change the way Scylla is maintaining schemas. We'd like to improve the database and introduce the notion of tablets. It's an area for a complete additional new talk, but it's opened the gate for really interesting use cases and more possibilities. Another long anticipated features is change data capture. Again, long anticipated feature, and really good one. We invested lots in thoughts and design how to do it right, and not just to throw you to handle the commit log like other databases do. And we have a really nice feature, and that also expands the usages that you can use with Scylla, because now you can interchange tables to streams and even vice versa, and A CDC stream is basically a table. Last but not least is user-defined functions. We have a temporal name for it called transformation because we'd like to make it more interesting than just run your function. And UDF will allow you to do fascinating things that you can basically run ETL on the server side and not on the client side, making it way more efficient, both in terms of manageability and also in terms of just the sheer performance and efficiency. So even today with our CDC, for instance, you can do something that you cannot do with DynamoDB. You can just, because the change stream is a table, a regular Scylla table that you can consume through CQL, you can actually filter that and consume just the events that you're interested in and not the entire stream of changes. And it's a great simplification and also an increase in efficiency. Scylla is a software. Scylla is we have a distinction where Scylla is the database and ScyllaDB is a company. So Scylla is a software has evolved a lot over the course of the past year. The company also evolved a lot. We had a major round of funding. The engineering force grew by 2x. We also grew by 2x the number of customers. Every dollar that you spend here goes back to you with product improvements. So keep on spending. Also, this is a graph from GitHub for the number of commits. We're continuing to the pace of innovation and to continue to push commits over and over. The beginning of the graph is just from the early days in 2015. So there were a large amount of changes back then, but now we still commit a lot of code on a daily manner, way more than other databases. And we're still trying to be as agile as possible. Not everything is performance or ease of use and more features. It's also about support. And I'm really glad and proud of the entire team here that joined hand multiple times. And I chose one story, but we have many stories where we help users to meet their deadlines or just to fix Scylla problems. Sometimes we do have bugs where you may. So one of the stories is that a customer needed a functionality called, let's call it Func6. And the functionality was coded in Scylla, but it wasn't really finalized. And by the time that the contract was signed with the late procurement teams, only then we had the time to really try to put it into a releasable state and QA it. So it started with Greg, who is managing the account, and Eyal, our good VP of Solutions, who collected the requirements, passed it to Shlomi, our VP of Engineering, and in parallel, Eyal, we do everything is in parallel, so Eyal asked Luis to verify that Luis on his first day on the job, and we have people coming from customers like Luis from GE, and it's fabulous. So Luis on his first day on the job started testing the open source version, and in parallel, Shlomi asked Pekka to build it, and Mikal, our head of Scylla Manager, verified that Scylla Manager works with that, so it's not just Scylla Core. Same with Amnon with the monitoring stack, and we had our QA team run all of the regular cycles and report back to the developers, to Kalle, who championed this feature, and several other developers who reviewed the code. So altogether, in the course of 2 weeks, we had lots of communication back and forth, multiple versions, multiple bugs were discovered, and we finally released the release on time for the customer. So it's really a pleasure to work with these people and have everything going many times without any involvement, and you have people who are ready to give everything for you. We have all of this for you, and now we're about to continue with the presentation. Now, Bob, our VP of Marketing, told me that, hey, you have all of these wonderful quotes by great leaders. Why don't you come up with something? So I looked at the theme. Yeah, thanks, Bob. So I looked at the theme, and like it looks like there's no much space left there. Like software is hitting the world, and the world becomes softer, and then, like is this the rise of the machine? So one thing I can tell you that if the machine will rise, guess which software they're going to select. So I can say this. I don't have a super wise sentence, but I can guarantee one thing. I can guarantee that Scylla is a damn good choice for your software, and we look forward to work with you for the course of the next 2 days or the next couple of years. Enjoy the conference, interact with everyone, and great for coming. Thank you.